Okay, some more notes on section 7.2, and we're just going to do some examples, and some of these are in the book, so we'll go through these. Just if you take a look at example number 1, that's what we're going to go through next. And again, this is on page 391. You can see you have the secant. They actually showed you the graph. This is the y equals the secant squared of x, and this is y equals the sine of x. And again, we're going to try to find the area between these two curves. So again, it's going to be top curve minus bottom curve. This would be the f of x. That would be the g of x. All right. And we're going to go from 0 to pi over 4, so you can see how this is definitely the top curve. All right. Okay, so you can take a look at that sketch. I didn't draw the sketch out on that one. Yeah, but here's the work. I probably filled in some of the steps. So this is example 1. So we want to find the area between these two curves, y equals the secant squared of x and y equals the sine of x between 0 and pi over 4. So again, I just used the general form that I gave you. Back on the first set of notes, the integral from a to b of f of x minus g of x, where f of x is the top curve, which was the sine squared of x by our graph, and g of x is the bottom curve, which is the sine of x. So I should say, hope I said secant squared of x. Okay, so f of x is secant squared of x is the top curve minus sine of x, g of x, the bottom curve. Okay, and then we just substitute those in, secant squared of x minus sine of x, the integral. And again, we can use our fundamental theorem of calculus by using the antiderivatives. The antiderivative of the secant squared of x is the tangent of x, and the antiderivative of the sine of x is negative cosine, and negative times the negative is positive. So I'm going to evaluate this. Okay, so these are my antiderivatives. So this would be my antiderivative of this, or the capital F of this, and then I'm going to evaluate this. So this is going to be f of b minus f of a. So this will represent actually the f of b, and this will represent the f of a. All right, I'll write that in just so you see. This is the actually, over here, this is the f of b minus f of a. That's from your second part of the fundamental theorem of calculus. So we're applying it all the time. Okay, and then the tangent of pi over 4 is 1, and the cosine of pi over 4 is the square root of 2 over 2. And the tangent of 0 is just 0, so I don't need to write that down. And the cosine of 0 is 1, so this is negative 1. These cancel, so that's what I've got. So not too difficult. Okay? Okay, this is number 2, example number 2, and you can read in your book. Find the area of the region enclosed by the parabola 2 minus x squared and the line y equals negative x. Now, they don't give us a limit, so we have to figure those out. Okay? And I drew a little sketch over here, it wasn't too difficult. And this is my line y equals negative x, that's just the negative diagonal, or the diagonal going through the origin with a slope of negative 1. All right, y equals negative x. This is the point 2, because this is the line y equals 2 minus x squared. And I just rewrote this as negative x squared plus 2, so you can see that it's just a parabola shaped like an N, shifted up 2 units. So that 2 represents that coordinate there, so it's going up to 2. Okay, didn't fill in all those coordinates here. This should be 0. I should put my 0 in. I don't have a lot of room on these things. There's negative 1, there's 2. All right. Now we want to find the area of this region, so we have to find out. So we know this is our top curve. That's no problem. This is the top curve. So you can see over here, 2 minus x squared is the top curve. I just put it back in that original form, and I call that equation number 1. This is equation number 2, and that was the bottom curve. Oh, but I want to take the area between these two curves, so it's going to be all these rectangles added up from here to here. So where is here, where is there? Where is here, and where is there? Okay, from here to there. So I have to find these points of intersection. So the easiest way to do that is just find out where the points have the same values. And that's the points of intersection. So we just set the left curve equal to the right curve. I'm sorry, the top curve equal to the bottom curve. Okay, so our equation 1 equal to equation 2. So 2 minus x squared equals negative x. Now sometimes you can do this with a calculator, and sometimes you can do it just analytically, without a calculator. Just algebraically, pardon me, not analytically, algebraically. Sometimes you can do it like that. And this is one of those cases, so be aware of that, because sometimes you'll have you might have a quiz or you might have a test question without a calculator, so you have to do these algebraically, which you can do. we just, like I said, to set it equal to each other, and then if I put everything on the right, I've got positive x squared, negative x plus 2. This is a nice simple trinomial. I can factor it. X minus 2 times x plus 1. Okay, signs are the same. Oh, that's a mistake, see? I don't have you guys to help me here, so. That should have been negative 2, pardon me. Subtract 2. Okay, should have been negative 2 because then when you factor it, you get the signs are different. Sign large is negative, so negative 2 plus 1. Okay. Alrighty. Okay, so this is x squared minus x minus 2 because I add x and I subtract 2, pardon me. Okay, you probably caught that before I did. Okay, so we got x minus 2 times x plus 1, then we check it. Negative 2 is, okay, negative 2x plus x is negative x, and that's negative 2, so that checks out. So my solutions are 2 and negative 1. So that's actually where they intersect, at x equals 2 and x equals negative 1. So those would be my limits of integration. So I'm going to integrate from negative 1 to 2. Okay, and I worked this all out arithmetically. Just if you don't have a calculator and you have to work this out, that's expected. You should be able to do this. So we can put this all in one polynomial. So we've got 2, negative x squared, positive x, and then we'll just take the antiderivative. And here we go. We've got 2x, okay, minus x cubed over 3, plus x squared over 2, and we're going to evaluate that from negative 1 to 2. And again, I'm going to apply the fundamental theorem of calculus, the second part. So this is going to be the f of b, and this is going to be the f of a. So remember that that's what you're doing. That's how valuable that fundamental theorem of calculus is. Okay? All right, so we can get exact values for our integrals rather than approximations. Okay? And remember, your calculator will give you approximations, so this is going to be more accurate. Okay, so if we substitute 2 in, we get 2 times 2, 8/3, plus 2 squared, which is 4 over 2, which is 2. Negative, and if I put negative 1 in here, I get negative 2. Negative times a negative, well, I get negative 1 cubed is negative 1 times the negative is positive, 1/3. And then negative 1 squared is 1/2. Okay, so you got a lot of arithmetic. Watch these signs, because you'll make a little simple sign error. You have to be careful. And then 4 plus 2 is 6 minus 8/3. And then over here, this is a negative 2. I'm sorry, a negative times a negative is positive 2. And a negative 1/3 and a negative 1/2. And then 6 plus 2 is 8. All right. And then 8/3, negative 8/3 and negative 1/3 is negative 9/3. So that's negative 3. So that combines to be negative 3 and then negative 1/2. So 8 minus 3 is 5. 5 minus 1/2 is 4.5, which is 9/2. So there's all the arithmetic. I don't think they showed all that in the book, so you get a chance to see all that arithmetic done. Okay? And again, be careful, double check your work. As you can see, it's easy to slip up a little bit on the algebra or the arithmetic. A lot of arithmetic in this, a lot of algebra. Make sure you keep those skills up, because you need to be able to do all that. So this is good practice. We'll do some more in just a moment.